and project management. But it's really just sort of thinking, I'm going to do a whistle-stop tour through the ways that I would sort of organize projects. There'll be the kinds of things that you are familiar with, you've heard about, maybe you use as well. So it might not be all be new content. Um, but I've certainly got a lot of experience of using lots of different ways to try to organize projects and knowing the ups and downs of those kinds of things. And there isn't really always one correct way. It depends entirely on the project, the circumstance, the team, etc. So I shall make a start, do a little introduction of myself. I hate doing this kind of thing, but I thought, seeing as though you guys you must be at some level rocket geeks. So I thought that I would begin with that. And instead of doing a super professional introduction of myself and my credentials, other than to say that I've got a background in material science and astronautics, I enjoyed playing around with rockets. This is a very, very, very old photo. So that's one of my kind of early rockets. And then I went from there to enjoying playing around with bigger rockets and making some quite big rockets and enjoying launching them in deserts, which of course is what we all really aspire and enjoy doing. And then working with rockets, even bigger rockets. This was the first private rocket company in the UK called Starchaser Industries. They certainly launched some extremely big rockets, and this rocket ended up at the new museum in New Mexico. From there to some even bigger rockets, I spent some time at Skyrora before I went on to found my own company, which is called Gravity Lab, which had a focus on developing new technologies for suborbital rockets. And that was certainly a really good experience, really fun, very busy, lots of project management and tight deadlines. And that's where I met Jack. I started my journey with launch about, I don't know, about 10 to 12 years ago, kind of before launch was a thing in the UK. And so I was part of working groups that led to all the sort of discussions and inputs into the regulations. Not that everything that we submitted from industry ended up being in the regulations, but it was a really interesting kind of formative time. It felt like anything was sort of possible to do with launch. And now, over a decade later, we're still kind of waiting for the first launch from the UK. Just a word on Exotopic, because you might not know much about us, although the company has run the MAC competition since its inception. So we're effectively a technology consultancy, which is why my job title is principal investigator. It sounds a little bit strange. We're not detectives. It's about generally supporting companies that are developing technology for the space sector, helping them grow their companies, develop their companies, find investment, and helping investors understand what technologies are worth investing in. So technology roadmaps. I wanted to talk to you about what a technology roadmap is. Why would you make one? And what do you do with it once it's complete? What's it for? So it's effectively a communication tool. It's not really like a piece of technical documentation which you would have in the canon of technical documents which supports your R&D, but it's nevertheless really, really important. It's really good for team cohesion because it's literally a map. It's your treasure map for how you're going to get to where you want to go. And so it's part kind of vision document and part sort of a technical document. So for me, I've broken it down into sort of five main kind of stages that I'm going to go through kind of one by one. I'm going to spend most of the time talking about gathering the information because that's sort of the difficult, interesting bit, and that's where it intersects with project planning, systems engineering, and all your kind of R&D that you'll be interested in. And I hope that this will maybe feed into some of the things that you're doing with your projects and the teams that you're in right now. But it might also give somewhat of a real world view on the things that I'm sure that you've come across in your undergrad degrees, the sort of basics of project planning and making R&D projects. So the first thing is the point of it really is to communicate your ideas really, really clearly. So this could be about making sure that the team are all on the same page about what you're doing. So you set goals together. It could be about letting the stakeholders know. So that could be the people in the competition. It could be the CAA if you're applying for a license to do something else, or it could be investors if you're trying to raise money for a company. So it's about being really, really super clear about that. What destination are you aiming for? Should be clear from the roadmap without you having to really explain it. So it's like a standalone document. Okay, so it shouldn't just be a whole bunch of pictures or information about R&D or about the technical specs of something that you're making. It's a narrative document really with technical input. Another thing that's worth doing always with if you're a company making a technology roadmap, is also saying about what the adjacent opportunities are along the way. What else does your technology unlock? Because the things that you're really interested in with your technology might not be the most immediately investable opportunities as well. So, as I said, the biggest chunk of this is really about how we gather the information for a roadmap, what goes into a roadmap. So the thing that your roadmap needs to have is a clear methodology about why you have chosen to include the things that you have. So it's not like a project overview document. It's not a business plan, although it could be part of a business plan. So you need to have rules about why you have chosen to talk about particular technologies, okay? And then you're going to describe what the enabling technologies are. That means the technologies that you need to develop in order to reach your goals. So not the things you'd like to do or R&D, which is interesting, but what do you actually need to do? And you can also include what you don't need to do. So if there are perfectly good COTS things or some other technology that you could buy or license, you don't need to develop yourself. It's worth making that clear as well. But the focus is going to be on the things that you actually need to do. And then there's a systems engineering plan and project planning element to it as well. So you're going to describe what the pathway is and how you're going to get there. It should include a TRL assessment and plan and a gap analysis. So TRL assessment is, I won't dwell on this. I think Jack might speak more about this in his systems engineering talk. But with ISO and ESA standards, there are clear guidelines about how you would measure TRL of something. And there are adaptive circumstances for whether you're taking something through technology transfer from elsewhere. A gap analysis is how you're kind of measuring your sort of actual results against what was expected, analyzing the gap and then figuring out how to bridge it. Starting with the methodology. So there's nothing more crippling than being told to just make something, absolutely anything. The composer Stravinsky famously said it was only when he was truly restricted that he felt truly free to be creative. So somebody said, write an hour's worth of music. It's absolutely crippling. It could be absolutely anything for what types of instruments, what volume, what do I include, where's it got to be performed. But if somebody says, write 20 minutes with tonal centers of G and D for string instruments, then it's at least a starting point. So you need to have some kind of high level sort of rules about what you're going to include. What are the expected outputs? What are you trying to achieve? And how are you going to have kind of gateways to accept or reject technologies? And then how are you going to define the technologies and how are you going to describe it? So this is a pretty sort of facile example really from a UK Space Agency roadmap, which just has a little kind of series of gates about why something is selected or not disqualified. It's extremely simple and obvious, but it's a good example, and it's worth making something yourself, because then all the choices become sort of less crippling. You need to create your own sort of boundaries really if they're not already imposed for you. And then your choices are defensible. They've met your criteria, your scoring criteria. We're going to talk a little bit about enabling technology. So as I said, this is the technology that you really need to deliver in order to be able to achieve your goals. So it's worth being able to sort of describe them adequately. And one of the ways to do that, you can use NASA guidelines, but the ESA guidelines are possibly more appropriate to us. And at any rate, they're quite similar. So I've included a link here. These slides will be available later, and you'll be able to click that and read about it and follow some of the ESA guidelines. ESA always describes things through trees, so whether that's work breakdown structures or document structures. And so there are trees related to how we're describing technologies. And there are three sort of main categories that you need to be able to kind of understand and not get them kind of backwards or mixed up. So you've got technology domains, you've got subdomains, and then you've got technology groups. And this is just a little example from ESA documents where it shows what the domain is, what the subdomains are, and then the technology groups. So it's worth being able to classify exactly what it is, the technology, exactly what the technology is, what type of technology that you're going to be developing, what it relates to, again, so that you can be super organized about what you're doing and you can use it to communicate really clearly to stakeholders, to regulators, to your team. Okay, so mostly about project planning rather than systems, but systems is an intrinsic part to it. So I wanted to just talk a tiny bit about the critical path. This again will probably be very familiar to many of you, but it's a really, really important thing to understand. It can be employed very, very simply, or it can be employed in a slightly more complex way for bigger projects where you've got bigger teams. So it's just a program management tool which allows you to identify the tasks that are necessary to complete the project and achieve your goals. So the critical path is the longest sequence of activities. Okay, so sequence of activities, things that have to go end to end in order to be able to complete the project and have the outputs that you want. So there are various steps that you need to go through in order to be able to identify the critical path. I'm going to talk about that in just a moment. But it's about discovering what the most important tasks are, identifying task dependencies, which are really, really critical. So what depends on something else, what can't begin until something else has been completed, and then calculating the task durations. It really helps make you more efficient. It helps plan your resources, financial and human resources, and avoids bottlenecks. It's every project manager's nightmare, a company's nightmare, startup nightmare, for 90% of the team to be waiting around for some very stressed, under pressure people to be able to finish something so that they can move on with what they're doing. Right. Okay, so dependencies. Dependencies are really, really critical. As I said, that they are the things that one thing literally depends on another. So in order to identify the dependencies, you need to have a discussion with your team. You need to understand the technology. You need to understand what needs to be done. So can you validate the dimensions of a design until you've done something else particularly? So for example, in the past, one of the situations you don't want to get into that I certainly have been in before is when one department is waiting on another, or all departments are waiting on one department. Generally with rockets, it's the engine that is the first thing on the critical path. That has to be done. The engine testing has to be done in order for you to then be able to dimension everything else and know that the performance is sufficient, etc., etc. So when it comes to rockets, that's going to be one of the clearest sort of things on the pathway. But then there are all kinds of things involved before that, before you get to engine testing, of course, about propellant choices. But it all relates back to your goals. So the clearer you are about what you're trying to achieve, then the easier this part of life is going to be. So finding the critical path. I've just done, again, I like short lists, a really short list of all the things that you need to do in order to identify and then be able to use critical path methodology. So you need to list all the project tasks, details. You need to identify the dependencies and then create a network diagram of those tasks. A really important thing, really quite difficult to do when you're not very experienced, is to estimate task duration. And even when you become more experienced, the first time you do it, it is quite difficult. But it's really important. You've got to estimate it, even if you're wrong. Now, if you don't know whether it's going to take you 3 hours or 3 weeks, then you might not be in the right role in the team. But you will have some idea of what you need to do and how long it's going to take you. And you can't dwell too much on the things you don't really know. If you don't know how long it's going to take to procure something, you've got to try to find out to the best of your ability. But things happen, life happens, and this is why we this is why we need these methods, so that we can cope with the things that come up that are unexpected or that are going to throw us off track. So finding the critical path is based on identifying the longest sequence, and then we can calculate something called float, which shows sort of how much kind of slack there is in the system in a way. Okay, so starting with the task. So you need to develop a work breakdown structure. So it's really simple. I'm sure that you're familiar with it. It's about just identifying all the tasks that need to be done and writing a work package for each one. The work packages can be quite simple, or they can be really, really complex. But it's best to start simple, start with what you know. So it's just a list of the activities that you need to do in order to be able to complete something. Then you organize them in ideally a tree structure if you're following an ESA method. Okay, identifying dependencies. So I can't sort of stress how critical they are, really. You'll get into a huge pickle if you don't spend enough time on the dependencies. So it's identifying where parallel working can take place. Parallel working is absolutely vital. You should do as many things in parallel as you can because it saves time, it saves money, and it's just a better way to work. But you can't do everything like that. You need to know what is dependent on what. So the activity sequence is a really, really essential thing to be able to understand properly. There are different elements that sort of play into this. So you've got sort of start to start, start to finish, things that you can identify. We'll talk a little bit more about that. So next is the network diagram of tasks, which is really quite straightforward. It's almost just like a little sort of flowchart, really. So you need to know what can go in sequence, what's related to what, and what depends on something else. So these hypothetical work packages, 3.1, it's related to, obviously it follows on from 2.1, and it relates to this sort of bluey colored line, and those things can't occur. Ignore that they're the same number. That's just a silly error. That they can't continue until that work package is done. So we really, the missing sort of metric here is duration. So how long do these take? That's what we need to know next. Gantt charts are a really important project management tool and a really good way of displaying the dependencies so that you can identify what goes what, where parallel work. And that's sort of the best way to be able to understand and look at and visually represent where work can be in parallel and where it has to be in sequence. Task duration, Jack will agree, there's much sort of gnashing of teeth estimating task durations when it's something you're doing for the first time. But you just have to bite the bullet and do it. And the next time it's easier, and the third time it's easier. And then it's the sign of an experienced engineer when you can estimate that with greater precision. You need to begin somewhere. You need to have some kind of idea, probably a discussion with suppliers, a discussion with the team about how long tasks are going to take. It's really, really important for all your planning that then you can begin to look at finding the critical path. So you need to write down the start and end times of each activity. And when I'm talking about an activity, I'm talking about a work package in your work breakdown structure. First activity has a start time of 0, of course, and the end time is the duration of the activity. The next activity's start time is the end time of the previous activity. You need to repeat this process slightly tediously for all of the activities, all the work packages that you've got. Look at the end time of the last activity in the sequence and determine the duration of the entire sequence. The sequence of activities with the longest duration is a critical path. So, for example, here we've got a similar kind of shape to the network diagram that we had, but now we've got days of duration in there, and we can see that some things are dependent on other. We can see what the critical path is, the longest route to get to the finish. So that means if you don't spend time on the things that are shorter, the green things at the top, you need to certainly begin with the things, the light blue color at the bottom. So the critical path formula, it's very, very, very simple, little bit of summing things up, but it's worth just spending the time when you're doing a project planning, really thinking about it. It's something called a forward pass and a backward pass. The forward pass calculates the earliest start times and finish times for each activity. The earliest finish is determined by adding the activity's duration to its earliest start. So the earliest finish equals the earliest start plus the time, the duration of the activities. The backward pass determines the latest start times and finish times setting for the latest finish, the final activity, is equal to the earliest finish, finding the latest start by subtracting the activity's duration. So latest finish minus time is the duration of the activity. Just whiz through that. Don't worry. It's just really simple summing, and you'll get these slides so you can have a look through it and think about it. So next, we're going to talk about float. So the float, or sort of slack in the system, refers to the amount of flexibility given to any given task. And it indicates how much a task can be delayed without impacting the subsequent tasks or the project end date. So finding the float is useful in gauging sort of how much flexibility the project has in general. And if you don't do something like this, when things get sticky and things get a bit out of sync and you feel under pressure, it becomes quite unpleasant. So it's sort of a bit of a stress release valve for the team to be able to do this and then have some kind of handle on it. So float's a pretty useful resource that can cover project risks and unexpected issues, namely to do with procurement, if not unsuccessful tests and designs. So critical tasks have zero float, which means that the dates are just set and that's it. Tasks with a positive float number belong in the sort of non-critical path setting, meaning that they can be delayed without affecting the project completion date. So if you're short on time or resources, non-critical tasks could be skipped. So the different types of float. So there's a total float is the amount of time that an activity can be delayed from the early start date without delaying the project finish or violating some kind of other schedule constraint. The free float refers to how long an activity can be delayed without impacting the following activity. And there can only be free float where two or more activities share a common successor, so where something converges. So on a network diagram that I showed you earlier, that's where things converge. So it's a really good idea to get a good understanding of the float in your projects. It helps projects run on time, and you're more likely to be able to avoid stressful situations if you can understand where you are in relation to float. Okay, so back to the overall list. Now, defining the risks. I won't do a huge thing on this because I'm sure that you know quite a bit about it and they're fairly straightforward, but I've just mentioned the two different types of risk that you should be tracking. So risk register is kind of like an overall big thing for your team, for the project overall. And then a risk table is a more kind of sort of detailed, granular thing, like, what if a test goes wrong? What safety mitigations are you going to put in place? Who's the owner of that, and what are they going to do about it? So one's kind of sort of like an organizational level, really, and then a risk table is at a project level. Okay, so then thinking about what are the key milestones which are going to go on your technology roadmap. So really, these are defined by how you have processed all the previous bits of information gathering that we've talked about. So then you can put some dates to those, which are really important, again, to communicate to your team, to communicate to stakeholders and competitions, and potentially to investors. Okay, so there are lots of different milestones that you can have, and it's really up to you. Okay, so there are start and ends of project phases. They're all the design reviews. So you've just done a PDR recently, CDRs, all those things that are really familiar. Production reviews, manufacturing readiness reviews, major inspection points, test reviews, delivery board reviews, funding milestones as well can be milestones on the technology roadmap as well. To say it's not really a technical document in an engineering sense. It's kind of a hybrid between a project document and a plan for your organization, as well as talking about technology. So you'll be really familiar with these kinds of things. This again is from ESA documentation, where we've got the phases and we've got all the kind of critical sort of technical milestones. But again, the technical milestones, and those aren't the only milestones that you will have. All right, so once you've gone through all of these tasks, you'll be ready to create the roadmap. You'll probably already have a good idea of what it is, because hopefully some time ago you agreed what your goals are with your team. So with roadmaps, it's a really good idea to make it a very visual document. Yeah, so it's not like a business plan where there'll be lots of text and graphs, but it's not a slideshow either. So it's a document or slide, but it's not just images. But you should make it as visual as you can in order to be able to illustrate where you are. So things like network diagrams are fine. Diagrams relating to the technology and your strategy, but nothing possibly very secret to do with IP, nothing that because it could be a public facing thing, it could be something that you send to people, so nothing that's really kind of very sensitive. Again, you'll get these slides, you'll be able to click on this and look at this. This is a link to the ESA space exploration roadmap, just to give you an idea, and you'll see that it's quite sort of an aspirational document. That is sort of like a kind of a vision document in a sense. And it's interesting looking at old technology roadmaps from space agencies and realizing all the things that they never really did. One of the difficulties with producing roadmaps, of course, is that it's quite difficult to fit it all on a page. It's like fitting Gantt charts onto a page. It doesn't really go very well. So the one thing I liked about this was just making a circular thing. So you can kind of illustrate it better rather than having sort of weird snaky shapes all down the slide. Something to think about a little bit more deeply, do your own research, is that there are many ways of assessing technology, looking at technology. So this is something called an object process diagram. Object process methodology is a conceptual modeling language and a methodology for capturing sort of knowledge and designing systems. So I think it was originally sort of created in the 60s. It can be applied to many different things, but it's really useful for looking at quite complex projects. And it sort of factors in human elements to do with technology, to do with physics, and it makes sort of graphical representations. So this is from an MIT object process diagram and a bunch of work that went into looking at small launcher roadmaps. One of the things that's really useful with your technology roadmap and that fed into the object process method is thinking about how you're scoring your decisions on technology and why you're choosing particular technologies. And figures of merit are really useful to do with that. So one thing you can do at the beginning of your technology roadmap is to list your own rules. So I showed you that little flowchart from a UK Space Agency roadmap at the beginning. You can have something like that and explain what your methodology about why you've chosen the things that you have. Figures of merit are really useful. What's really important? Is it the cost per kilogram? Is it launch frequency, reliability? Okay, all of these things are probably quite important. And depending on, whatever you're doing, it's good to figure out what the figures of merit are, what units you're talking about, and then you are able to score different technologies to achieve your goals. Okay, so structures of the document, of the roadmap. It's good to have an introduction, really clearly define your goals, include the methodology, and include the things that sort of support your decisions, that show how you've made your decisions, how you've done your working out, and what you're going to include and what your R&D is going to comprise. Flowcharts, diagrams are really useful, help people understand visually rather than using text. Think about the technology focus areas, include a narrative as well as diagrams. Think about how you're going to fund it, even if the projects that you're doing right now, you'll have some funding constraints. Include that. Maybe you made a decision about a particular technology because of funding constraints. Everybody does in the world. And then visual representations of the progress through time with milestones, key events are really good communication tools. So share the roadmap. There's no point. It's not really just an internal document. It's about showing it to people. You can share it with universities, have it on your website. You can share it with Exotopic if you like. You could share it with the CAA, share it with the people who are funding you. and get the team to buy into it. If you're all working towards the same goals, then everything to do with technology and engineering and R&D is just going to go a lot better. Okay, I hope that you have enjoyed that little whiz through technology road mapping.